Now, let us understand database design and ER modeling. Database design is a collection of tasks which help us to design, develop, implement, and maintain the database. So, in case if we design the database properly, it reduces a lot of cost because the changes need not be done at a later stage. It improves data consistency, and the cost effective measures are in place so that disk space is not wasted. We develop logical model and physical model. Now logical model is concentrated more on the requirements of the data and what are the other considerations from the end user, and the physical database design is more about what physical features are used, like what hardware and what software are getting used. So why do we need a database design? Database design is the blueprint of how the data is going to be stored. It gives us a clear idea of the behavior of the application and how the requests are to be processed. It helps us to know the proper database design, and if it is done properly, it will meet the requirements of the user. The processing time of the application is greatly reduced if the constraints of the database are properly implemented. So, initially, the requirements are collected. This could be function requirements and database requirements. Function requirements means the overall functionality. And then there are database requirements. So, database requirements, as in what data and data type is to be stored. So, that is requirements analysis. Once we gather that, we move on to the next step, that is, we develop a conceptual design. Now, conceptual design is done using high level conceptual data model, that is something like ER model, and it is not concerned with what are going to be the implementation details. It is just to make sure that we have understood the requirements properly. The third step is logical design. Now logical design is using representation data model, like in the form of tables. So conceptual schema gets translated into the relational model. So this can be done using representation data model, which can be either relational, network, hierarchical. It all depends upon what data, what DBMS are we using. And the last one is the physical design. Under physical design, we given the internal details like internal storage structure, access paths, file organization,